No.
Okay. Yeah, do you understand what this problem is saying? So, I guess.
How to do it?
So I don't want to make a big fuss about the problem because some of the stuff I'm going to say later is related to this problem. Like, it's not like we have to invent all this theory just to solve this problem, okay? It's more like it's kind of nice that we can solve this problem geometrically, okay? And that's what I want to explore in the next part of the class, okay? For now, you might want to know that you don't actually have to solve it geometrically. There's like a pretty nice way to solve it. Just
Which one?
So this one.
Oh, okay.
So one nice thing to do about this is, so it's kind of weird. It's like so because they're sides of a triangle, right? Can you see the expressions? Shh. I don't want to have to talk over you because I have like a sore throat and everything. Okay, so can you see that like b plus c minus a is positive? Yeah. Yeah.
Yeah.
Because they're on this triangle.
Yeah.
Because of the triangle inequality, all those three numbers are positive. Yeah.
Yeah.
So what you can do is you can actually look at this equation here. Yeah. You see that one? So you can do that equation. So what you can do is you can let so instead of using a, b, and c for this equation, use like x, y, and z. Yeah.
Wait.
Yeah. And then you can let x equal a plus b minus c on 2. So does that make sense? So we have that x plus y times y plus z times z plus a is greater than or equal to 8 x, y, z, right? For any a. So we can let x equals b plus, oh, of course, like when you're actually doing the problem, you're going to be expanding stuff, and probably there's lots of basic ways to solve it, but this is probably the nicest overall solution. So x is equal to b plus c minus a. I guess you could start with a plus b minus c, but it doesn't really matter. On 2, yeah? Y equals c plus a minus b on 2, and z equals a plus b minus c on 2, yeah? So if you do that, what's 8xyz? Well, the 8 just cancels all the 2's, yeah? And then xyz is just the left-hand side now, right?
Oh.
So this is now the left-hand side, yeah?
Yeah.
Okay, now look, what happens if you do x plus y?
Wait. Yeah.
So x plus y, the a's cancel, right?
B's cancel.
B's cancel, and then 2c on 2.
Yeah.
Yeah?
Which is that?
We did it.
Y plus z equals something else. A. And z plus a equals b, right?
Yeah.
Z plus.
Michael, how are you so smart?
Z plus.
Oh, no,
How do you come up with this?
No, I didn't come up with this. I knew the solution. So
How do you come up with this? What's the motivation for like
Wasn't it like doing the other ways?
insane?
yeah. But every problem that I show you the solution to, I have come up with my own solution. Yeah. So the problem I showed you before is my solution, and then I'm gonna try to show you maybe like a geometric solution to this. Okay, which might make more sense, even though it's not like this one shot kill with this substitution, right? So one way you might realize this, you can So one way you might see this is if you actually go through the expansions and stuff and do it like the dirtiest way possible, right? That this problem actually probably involves like completing the square at some points, yeah? And the proof of AMGM for the two variable case is just completing the square, right? So this formula, which uses AMGM, is capturing a lot of the completing the squares. So there's a chance that you could save yourself completing the square over and over again with something that already has that integrated into its proof. Okay. Okay. So power of a point is the next part. Alright, you guys know what power of a point is?
Yep.
Alright, so I'll just quickly remind you what it is. So if you have like a circle, right? So maybe this is the most obvious situation. So you have a point P, yeah? So do you know that like if this was little a and this was little b and this was like big B and that was big A, yeah? Then A times big A is always equal to B times big B. You know? So the reason behind that, I mean, there's lots of ways to see it, but one of the ways you can see it, for example, is if you know about cyclic quads, right? You know, this angle is equal to that angle, yeah? This angle is equal to this angle, yeah? And so the small triangle is similar to the big triangle, yeah? And so A on B is equal to B on A, yeah?
Okay, Michael, I did the impossible question.
Oh, good.
Like this, the first proof I did it wrong.
Okay, we can present it next week. Or at the end.
I'm gonna forget it by then.
Okay, at the end, okay, at about 8. Yeah. Okay, so the reason it's called the power, so this expression here, right, is called the power of a point, yeah? The reason it's called the power of a point is because it doesn't depend, it only depends on where the point actually is, yeah? It doesn't depend on which line you cut the circle with. That makes sense? So no matter where you cut the circle, it's going to have the same value. So that value is called the power of the point. And it actually also works inside the circle, but I can't be bothered to really go through it. Like you're going to have a point inside. And it's like, this will be like x times y equals w times z. Okay. 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 So can you see? So basically one of the most basic things about power of a point. So you need a point and a circle, yeah. So it's the power of a point with respect to the circle. Okay. And one of the most basic things is that it's equal to. So like, if d is the distance from the center, it's equal to the radius of the circle squared minus the distance between the point and the center of the circle squared. Do I have the right way around? I think I have it backwards, right? Huh?
What is that? What's
This?
like what's this?
Oh, maybe we can just prove it, then we'll know what the formula looks like, yeah? So basically, I'm trying to say that if you have a circle with this center O and radius R, yeah? Yeah? Then the power of a point P, yeah, has some formula that only depends on So maybe we can line it up with a radius. So let's call this D. Yeah. So the power of a point of P with respect to the circle has a formula in terms of D and R. Is that obvious? You know what I'm talking about?
Use that.
Yeah, so use that as the line, right? So this is R, yeah? So basically I need to the power of a point is the little distance here, right? So this is D minus R, yeah?
And the other is D.
And the other one's D plus R, so it's D minus R times D plus R, yeah?
No,
It's D squared minus.
So it's D squared minus R squared. So I was the wrong way around, it was backwards.
Okay.
Okay. So the goal for what we're gonna do is we're trying to calculate the power of a point. So we need a point and a circle, yeah? To try to calculate the power of a point of that point with respect to that circle. Okay? So the point we're gonna take. Let me just draw this diagram. Okay, so the point okay, so the point we're gonna take is the incenter of this triangle, yeah? And the circle we're gonna take is the circumcircle. So we want the power, I guess we want the power of the incenter with respect to like the circumcircle. Something like this. Okay? That makes sense? Okay. So maybe the
What is it?
so maybe I'll draw this diagram, you can think about it. Let me draw this. It's the center.
How to get this? I'll
D.
figure out what the power of the point is.
Yeah,
Power
so
of
which
the-
oh oops. Undo.
How hard?
So
Schizophrenic.
maybe I'll draw some extra lines in.
Ortho center.
So this is called L. This is called
No, that's the origin of the stuff. Which is also the ortho center of the triangle. Wait, is that the circumcenter or? That's the circumcenter. Yes.
Yeah.
Yes.
okay, so from this diagram, oh, okay, and what are we calculating with respect to, yeah? So we want to calculate the power with respect to, so we want the formula to be in terms of D. No, we want to calculate D, right?
Yes.
So we want the formula to be in terms of R and R.
Wait, what's big R?
Big R is the circumradius, yeah, and little r is the in radius.
What's the circumradius? Wait, what? Oh, wait.
So big R is the radius of the circle that's drawn, yeah?
Oh.
Little r, I guess, maybe I'll mark in little r. So
What is little r? Where is little? Yes, where is
so
little?
little r would be like from I to the perpendicular distance of the side, yeah? That makes sense?
How do I do? I've used enough brain. No, I can do this. R
Self-aware.
D. I indicate self-awareness.
Okay, so maybe to label these, so because the angle bisectors is what meets as the at the incenter, right?
Yes.
So those are like alpha, yeah. Maybe this could be like beta.
Beta 1. I am a beta male. Ah.
Yeah.
Right. I made a ring.
Yeah, so maybe instead of me just reading out the answer to you, maybe you can see stuff and tell me what you see, yeah?
Maybe like draw a third line.
The third line.
What?
Oh, like this one. That's a good suggestion.
And what's the diameter?
This is 90 degrees. That is 90 degrees. So that minus that is beta. That much.
That minus that.
90 minus the weird thing is. Yeah, it's just the weird thing. You are the weird thing. Wait, then that means they just die. Just die.
Well,
Wait, no, can you zoom out fully?
hold on. I can't move it for some reason.
Can you zoom out fully? Interesting. So.
Oh no, the whiteboard has died. It has reached
Can you
critical.
access the whiteboard?
It has reached critical mass and collapsed into a black hole instantly. Just had too much math on it. Couldn't deal with it and just killed it.
I feel like my screen has...
Why is your mouse so thick now?
Chromecast.
His mouse is thick.
Whoa, what's... Yeah.
Okay, let's just do it literally, okay? So I don't know how to do this.
Yeah, so remember, we're trying to basically find...
I got this. So, so what would it be? It would be D minus R, D plus R. I mean, R minus D, R plus D equals, and then the other thing.
We're trying to get it in some slow.
Yeah. Oh.
So remember, the formula we got is d squared minus r squared, but that little r is a bit confusing because it's meant to be the radius of the circle, right?
Can we do something with respect to the
So we want to find an expression in this case for d squared minus big R squared, right? That's what we want.
Well, that's.
Can you do something with respect to the incircle? So it's like.
Oh, by the way, what do we like? Can we expect the answer to be negative or positive, for example?
What?
Will the answer be negative or positive?
Positive, right?
What does positive mean?
It has a plus sign at the front.
No, well.
Well, no, it might be negative because R squared is much bigger than D squared.
Yeah. So remember the power of a point inside the circle is actually negative, right? Because the distance is less than the radius, right? So d squared minus r squared is negative. If the point's outside the circle, it's positive.
So what do we do with D squared minus R squared?
Yeah, so I guess the definition for the power is sort of a little bit different when it's inside, just because we're trying to extend that formula.
With respect to.
Well, what is R's ratio to D?
That's what we're trying
So
to
should
find
the
out.
power be negative or should
Yeah, it should end up being negative. So I guess we didn't quite define what happens when it's inside the circle very clearly. But yeah, so we're essentially, to make it the problem, well defined. We're trying to basically figure out d squared minus capital R squared. Yeah.
Your sauce.
That's cringe.
Cringe. I don't know what to do. Help me. I need help.
Is it clear what the angle at M is?
What?
Is it clear what the angle at M is?
What's that?
M is up.
M is the. Oh, you can't see it.
Oh, it's the negative sign. I mean the inverse. It's the sign of
Alpha.
It's alpha, yeah.
Wait. Oh right. Yeah. Oh.
Wait.
I'm brain dead.
Oh my god.
It's bow tie theorem, boys. It's literally
smart. Oh my god.
this is bow tie theorem.
Look, this is like 5 head people being dumb. Oh, but then BLM is 90 minus 10.
BLM. What?
Wait,
BLM.
No,
Wait, okay.
Oh.
Okay.
it's not even worth talking about.
Wait, then that means that part is okay. No, it doesn't.
It's also equal to sine 1/2.
MLB is It's
What is sine half?
It's 90 minus
And inverse sine half. Sorry.
It's 90 minus
That's like
right?
Hmm?
yeah.
MLB 90 minus
30.
alpha.
MLB, yes, 90 minus alpha.
We're just passing.
Okay, let's do some trig. So cold. Whoa. Alex, did you know this? Yo.
Yeah.
You just said cos equals tan.
Why is 6 afraid of 7? Cos 7, 8, 9. Yeah, that's from math. No, he literally just showed on the board the value of cos 7, 8.
And 5 was too far away to see it, right?
Wait, Michael. What is tan squared x equal to?
I don't know. What do
Why
you
am I
mean?
dumb?
Well, that expresses it as I think it was
Tan squared x is like sec squared x minus
Wait,
1.
hold on. So how can we use zero-type theorem or something again? Or is that not possible?
Oh, by the way, where's big R in this diagram?
OL.
LM? OL. Yeah, OL, yeah.
OL.
So LM is 2R, right?
Okay, press laptop, yeah.
Yeah.
I need an
So it's good you know that because you need to find d squared minus r squared.
Yes, it is. Tan. Tan, power 2. And then open bracket.
I don't really understand why 10 squared x is like relevant.
What are you doing?
Oh, you did the bracket wrong. There's a difference. Sine x
Did it
over 1
just
plus
fail
cos
again?
x. See, I told you there's a difference.
Because I saw the light change.
Oh,
Why
yeah.
did it fail?
Something failed. Something always fails. It's failing.
Me?
Huh?
Did
And
I
we have
fail?
u sub me.
I failed.
No, you're far from failing. Okay.
Wait, you can extend that. Wait, no. Wait, yes, wait, no.
And then we use u sub, u equals
What? What?
u
What the
equals
hell?
sine
What?
x.
What?
What? What is cat?
Wait,
What
is
is
beta?
Kevin doing? He is doing Kevin.
But it's d over
Is beta
Kevin
IBC?
Huh?
Is beta IBC?
Yeah. Yeah, beta is this.
Why?
So LBC is not.
Downloads record.
Yeah.
That's a
So can you guys see that this is also alpha?
Wait, what?
Yeah.
Oh yeah.
So
What's also
innocent.
alpha?
Oh, LC.
What was the
Yeah.
Oh
Oh.
my god, that's 90. Okay.
Oh,
Oh.
alpha.
What was
Oh.
the derivative of
Oh.
What are you
What?
doing?
What
was the derivative of sin x again? What are you doing? Michael, what was the derivative of sin x again?
Cos x, but I didn't see how.
What are you doing?
Yeah, see, this is like, it feels like it should have been relevant just because of the context in which he said it. But the things he said just cannot be relevant, can it?
Okay, so now what do we do?
Hmm.
We have the How is it so? Dude, they have zoom. And the shutter speed increases and decreases based on zoom. Bruh.
Like what?
Oh, this is
No, that is the shutter speed.
Why is it so slow?
the speed is 1 second.
Okay, let's see. So,
Is 1
Increase the.
How do we-
Oh my god.
Oh.
I didn't even get that. Oh,
Okay, how about this?
How-
Do you see that this angle here?
I can't see anything before you show it. So
Wait, it was that.
Can you see why that angle there? Is that angle there interesting?
Which angle?
The one I just marked without, like,
that's 2A.
Greeking
Alpha. 2 alpha. Wait, no.
LIB?
It-
Library?
wait.
No, it's not. No, it's
It's
not.
not.
No, that's not.
what's interesting about that angle?
Mm.
Hmm.
It's actually good that you came because the online thing didn't work at all.
Please cancel so then it's
This
just
is a
What are
complete
you
guess, okay?
Complete guess.
Yes, it's a complete guess. So if you're gonna ask me why, there's no explanation.
Okay.
Is it alpha plus beta?
Oh, this complete guess is on the money, huh?
Wow. How could this possibly have happened?
IDL
It just
is.
But why is it alpha plus beta?
I'm thinking.
That's chain rule.
What? What? This guy.
He's just here to fund you
I was
guys.
using USUP for integration. You're still doing it. Wait, was USUP integration? No, USUP was integration.
So notice actually AIL is a straight line, yes?
Wait, yeah, USUP was integration.
Yeah.
The chain rule was.
That's how IL was defined.
derivatives.
Oh yeah.
Yes, right?
E. It's useful
For what?
when the table is flat.
Actually, I guess we're proving something we already know, yeah?
If the table
Oh,
is flat,
oh,
then
yeah,
you can
yeah,
take
yeah.
flat photos of
Because that's beta,
Your table is flat.
Yeah.
and then that.
My table is
Yeah, so it's the exterior angle, right?
What?
So in triangle BIA, yeah?
BIA. Oh.
The exterior angle is alpha plus beta, yeah?
Alright, yeah.
Because there's alpha and beta on the inside.
Big brain.
Yeah. But like,
Where did I go wrong?
But what does this show? This just shows something we sort of already knew, that this point here is equidistant from I and B and C, right? Because now it's isosceles.
Yeah.
So easily right.
I'm not using the word
Yeah, okay.
I now have a compass.
Are you flat?
I have a compass.
Are you flat?
This is pretty famous.
I can't tell. No, I have to put it on it. Yes.
Oh, I'm blind.
Yeah, I think minus.
What? Slide.
I can't tell. Okay, this means I'm fat.
Wrong way. Wrong way.
Because if you're not flat, you're fat.
Everyone's cut.
It's D over.
Okay, let's see.
North just went from there to there.
Wait a minute. Albert.
Alright guys, are you still trying?
So,
I don't know where to go.
So I guess it's clear now that BL equals BI, yeah? IL.
BL
Yes.
equals IL, yes.
Yeah.
Indeed, Bill. Bill.
Blur equals ill.
Look.
Block.
Look.
Block equals ill.
Oh, what was it?
Yes.
Is LC equal to LB?
Wait, LC? Yes.
I think so.
Yes, it is, I think.
Why?
I don't know. Just don't ask me why. So that's just how it is.
That's the whole point.
So LC equals LB, right?
Yes.
Wait,
Don't
why?
ask me why.
Why?
Because L is the midpoint of the arc BC because it comes from the angle
Oh my god, I actually
bisector.
got it right.
So
yeah,
if,
but
if
how
the
do you prove that the angle by... Oh,
because if the
wait.
angles are equal, then the chords, the the arcs are equal.
Oh my god, I actually got it right.
Oh.
Happiness.
You got what right? This question? No.
No, the indefinite integral of sin x over 1 over 1 minus x.
Bruh.
Which you do using yourself.
Bruh.
Oh, sorry, Michael. Am I being disruptive?
Yes.
Oh, okay.
R squared minus D squared.
I have max on her. And I still
Wait,
can't figure it out.
Michael,
Yes.
what time is it?
It's 7:06.
Time to get a
Can I
walk.
present the impossible problem?
It's time
No.
to get a walk.
No.
Can I present the impossible problem?
When it becomes more relevant to what we're
This
doing.
one is not going to become relevant at all.
Yeah, because there's a discussion that's not finished.
Yes, sir.
So how to proceed?
So,
Okay.
All roasted. Why is 0 so much? Why is 0 to be so wide?
It's this.
Oh. Why does it not 0 degrees to be so too much?
It's measuring this.
Mm.
It's not measuring.
So confused. Why does
Measuring
it
this.
stop being 0 when you do that?
So is this true? If R squared minus D squared
R squared minus D
equals... So R squared minus D squared equals Li times Ia.
Yes.
Wait.
Why is that?
Wait, why did we have? Wait, what? Did you say?
Li times.
What did we have to write the power in terms of? Like,
Oh, in terms of little r and big R.
Wait, Li times.
yeah, because
Oh.
Li times IA is
Yeah,
just,
therefore Li minus I. Wait.
Yeah, so that's just the power of I. That's like the negative of the power of I, right?
Yeah.
So
Li minus I is.
Wait, so R squared minus D squared.
yeah, so I guess it's like if you have a power, if the point's in the inside, right?
But then shouldn't R squared minus D squared equal to negative Li times?
Yes.
No, D squared minus R squared equals negative
Yeah.
Li times R.
Oh.
Yeah.
Oh, and that's the other one. Wait, so aren't we just trying to find D in terms
This is
of
log
R?
brain. Wait. So
Powers of D plus R times R minus
this
D.
forward. Like that. So how is this relevant to small r?
Somehow small r is gonna be, and D is gonna be in terms of small r.
Well, what's natural to do here, right? Li we just showed was equal to BL, right?
BL.
So BL and IA.
AR.
Hmm.
So how can BL?
Real.
How can I BL with Leo?
And how is IA related to anything?
Well, wait, no.
Well, wait, no.
Well, wait.
So, for example, like if you know a bit of trig, IA is equal, well,
Oh.
like sine alpha is R on IA, right?
Equals R,
Yeah.
Yeah. So
R, A sine stuff.
it's R on sine alpha. Yeah.
Yeah.
So that's good. We got the R. Yeah. But we still want to get rid of the alpha and the BL, but alpha is nice because we have lots of alphas, right?
We have lots of.
And look, BL is in this big triangle, right? BL is in a big right angle triangle. Yeah.
Yeah.
So actually notice that sine alpha, yeah? You see sine alpha is equal to BL on 2R.
Yeah.
Yeah.
Yeah?
Yeah.
Yeah, so that's actually the sine rule basically. But like
Negative.
um
Yeah.
Wait, so now we have like the
Okay, Ryan, let me. 0, 1.
yeah.
so now we have like can we simplify it? Because
Okay, so BL.
yes, that
We need to figure. Okay, so that's R, right? R, BM. What is BM?
BM.
What is BM?
I mean, you
I
say
think BM, but what is
I'm
BM?
not even sure if it's BM.
Wait, no, we can just trigonometry this one as well. So we obviously have 2R. 2R.
2R.
That. So it's like. Yeah.
Wait, but can't you see we're done? We have all the letters.
Yeah, you just
Yeah, we just need to make BL like sign of something.
blur.
Sign of
Blur
alpha.
on
But then you see that BL on sine alpha is just equal to 2R, right?
Yeah.
Yeah? From this.
wait,
So
oh
it's
yeah,
just 2R. Yeah.
So then this equals R times 2R, right? Yeah? From this.
yeah.
Okay.
So isn't the answer negative 2R?
Yeah, so the answer is negative 2R. Yeah.
E.
Okay, so the power is negative 2R. And I guess the equation we can write is
Wait, so can we determine
R
D?
squared minus D squared equals 2RR. or we can write d squared equals r squared minus 2r. Yeah?
Oh.
Yeah.
So we can figure out d squared if we know r and r.
Yeah. Basically, yeah. And so the power of a point of the incenter with respect to the circumcircle is just minus 2 times the product of the radii. Yeah?
Oh, okay.
Okay.
Interesting.
So actually an interesting inequality comes out of this. I mean, it's just obviously from this expression, right? Can you see that the circumradius is bigger than or equal to 2 times the inradius?
Wait, let me see. 2 times 8.
Yeah? That obvious?
Yes. Yes.
Okay, let me look through the whole Oh!
Yeah.
Right, because this is positive, the d squared is positive, yeah?
Yeah.
It goes these things.
And then r of
R is like bigger than
r minus 2r, yeah? So that's positive, yeah?
Yeah.
Yep.
And so that means r has to be positive. R is already
Oh,
positive and r minus 2r is positive, yeah?
And so r has to be larger.
Or equal to 2r, yeah?
Yeah.
Okay, so that's an inequality, right? So let us revisit our inequalities. So remember we had a plus b minus c times b plus c minus a, yeah?
Yes.
C plus a minus b is less than or equal to 8ab, wait, just abc, yeah? Okay. So remember, so the motivation for this is because the left-hand side looks like the same kind of stuff that's in Heron's formula, yeah?
Oh,
Oh, Heron's formula, so let me just remind you. So the area of a triangle, yeah,
actually, how did you get it? Where did you get this from?
is equal to root
Oh,
s times s minus a.
Heron Formula.
So this is called Heron's formula.
yeah.
Lots of ways to prove it. It's actually a pretty good school exercise because actually, if you guys are interested in some of these trig things, I can send you a little thing I did a long time ago. But some people should have already done it by now. Okay, so
Is that supposed to be s minus c?
sorry, yeah, s minus a, b, and c. Yeah, and s is called the semi-perimeter. It's half the perimeter. Yeah.
Oh.
Yeah, so this would be my approach to solving this inequality because it makes more sense to me.
Didn't I like point this out to you last week?
Huh?
Yeah, we referenced Heron's Formula.
Yeah.
Was like,
Michael's like, I'm hiding something and you don't know.
Michael's hiding many things.
Alright, so a plus b plus c minus 2c is what the first bracket becomes, yeah?
Indeed.
So you can do a plus b minus 2a, a plus b plus c. Actually, I'm not sure if I even checked if this works, but let's just see.
Yeah.
So, so if you put that, a plus b plus c is just 2s, right?
Yeah.
Okay. So you have 2s minus 2c is that, right? So then when you get
Oh,
when you take out the 2's,
that's 8.
you get 8 times
8
s minus c,
8.
s minus a, s minus b. Yeah?
Yeah.
So then,
So basically, if you times both sides by s, yeah?
S.
S, A, B, C, yeah?
Sabka.
So you're trying to show that basically 8 times the area squared, right? Is less than or equal to subco. Yeah, that's what Alex said.
suck.
Does that make sense?
Sabka.
8 times the area squared is less than or equal to s times ABC. Yeah?
Well, this seems awfully relevant.
Yeah. So in school, like, you'll learn some of these formulas in school anyway, so I don't want to necessarily waste time proving them. But like one way you can get like an expression like ABC from the area, right? Is, did you know the area of a triangle is half AB sine C? Have you learned this?
Yeah.
Wait, sine C.
Maybe sine
Look
C.
at the sine rule thing.
Wait,
What's AB?
you guys
Law of
got my
science.
bottle once each. My bottle's actually gonna break before this lesson ends.
So this is like A, this is like B, this is like C, yeah?
I'm a wise man.
Oh, okay.
C is an angle.
Yeah,
Yeah, I thought C was like the sine. And like, how do you take a sine of a sine?
yeah. And did you
What
know
is the
that?
sine of 28 centimeters?
And you know that sine C. Okay, and then there's this extended sine rule that says if you have a triangle, right? So this formula is from school, yeah?
Yes.
Okay, then you
No,
have A.
Australian math curriculum.
You probably learned this in like year 6 in China.
What? I just, yeah.
Yeah, so basically you can move. So this is the extended sine rule, right? You can move this point here across the diameter, yeah?
Well,
Oh, oops.
diameter. Wait.
So here. So move this point over to here, yeah? And the angle is the same, yeah?
Wait, that's
Yeah.
Wait, that's just bow tie.
Yeah, so the
Yeah.
point I'm trying to make is now sine C is equal to little c on 2r, right?
Yes.
Yeah?
Correct.
That's the extended sine rule. So then what you get is the
Wait,
area.
The C's all look the same size. Like, which one is little c?
Which one's
The angles of the big.
the big C and then that's
The little c is the of the side.
small C.
That's a big C, yeah. Alright. Okay, so then the area is equal to half ABC
C over to
on 2r, right?
So then that's just RABC.
ABC on
What?
4r.
No, IBC on 4.
Yeah.
I can't think.
Okay, so 8a squared, yeah, from that formula.
What's R?
So 8a squared then from that formula, right, would then just be 2. Wait, so how would you square this? So it'd be 1 on 16 r squared. So it'd be a squared, b squared, c squared,
On 16 or
16 r squared, and then you times it by 8, right?
So then it's over 2 R squared.
So that's a squared, b squared, c squared on 2r squared, yeah?
Whoa. Wait, is R constant?
Huh?
Like, is R equal to 2 pi? Wait, no, what am I on? What am I on? Alex, what am I on?
Magic mushroom.
Yes.
Yeah, so we're trying to compare this expression here, right, with s times abc, yeah?
I'm on,
Does that make sense?
yes.
We're trying to compare it with s times abc. We're trying to show it's less than or equal to s abc, yeah?
E.
So the ABCs cancel, then it suffices to prove that ABC on 2r squared is less than or equal to s, right?
Yep.
Or ABC is less than or equal to 2r squared s. Yeah?
And how do we do that?
Wait a minute.
Oh.
As you can see, Michael was doing the funny trigonometry thing.
Oh, actually, maybe I'll keep it under here. 2r squared, yeah?
Yes?
Oh. Okay, actually, maybe I need to manipulate this some more. So, ABC on 4r, we actually know that's something, right? So we need to show that's less than or equal to 2. So we
Yes.
so s
Just
times r, yeah? Maybe there's a 2 somewhere as well. Yeah? A 2 or on 2?
want to divide. Now why do we have this? Michael explain.
This seems kind of sucks.
Yes, but Michael's gonna do some trigonometry trick. We're like, SR over 2 equals.
So we're trying to show the area is less than or equal to SR over 2, right?
Yeah.
You're not seeing my error messages. Okay.
You're not seeing my error message. Okay.
Bruh.
So we're trying to show the area is less than or equal to S capital R over 2, yeah?
Yep.
Yeah.
Are we all agreed on that so far?
How?
Please make sure you agree on it, because I'm not actually checking.
I agree on it.
Okay, but what is the area? Do you remember? Like,
Area is S.
so we want to show.
Root. Well, it's root.
So we want to show the area is less than or equal to
SR over 2.
SR over 2, yeah?
Yeah.
Remember, so we want to get the in radius into this, yeah? So remember that we also have a formula for the area in terms of the in radius. Yeah, it's pretty simple. It's like area equals.
Suddenly,
In
Michael has
radius.
a trick that we didn't know.
Suddenly, Michael.
No, I mean it's obvious, right? Like,
Michael
yeah,
is
He pulls out of his.
alright.
Michael's
No,
shoving Michael's shoving like 11 different formulas into this one question.
no, but these are all obvious, yeah. So,
Not for us. Did you know this when you were in year 9?
huh?
Did you know this when you were in year 9?
No.
Then why are you
Suddenly,
expecting us to know?
he pulls out of his hat.
Yeah, but
a huge-
So like
This is
I never learned this
obvious.
stuff in year 9, but when I went through this, I never saw proofs of these things. I just like when you need it, you can figure it out.
It's R times A,
So-
B,
You just gotta hold this.
A plus B plus C divided by 2.
So like if I ever saw it stated, I could just prove it myself. Or if I ever needed it in a proof. Like in this case, I
how
needed
did
it
we
in a
get from an inequality to geometry?
yeah, it's nice, isn't it?
No, it's not.
So it has something to do with Jackie wanting to do
What's
geometry.
that?
Motivation
Why
for
did you-
turning that question into
Sorry,
this.
I don't enjoy this anymore.
I don't know.
Oh, what? Oh, that's a
say you do,
shame.
say you do, otherwise you'll stop and get rid of it.
Okay, so look at this is the in circle, right?
Let's just let him continue. Complete the
How did you
So
get
look at this in circle, yeah? Can you see,
Yeah,
can you
so
see the
it's
triangle? And then this is side A, let's say, right?
It's like a
Yeah.
So it's just
So the area of this triangle, yeah,
R times A, B, C over.
it's just R times A on 2, yeah?
Whoa. And it's awesome B over 2, awesome C over 2.
Yeah, so it's just R times little s, right? That's the area.
Whoa.
Michael just pulls this out. Wait, that's. Wow. I think
Yeah.
I've seen A plus B plus C.
Hold up.
What?
Kevin is excited.
Wait, do you see it?
How did we get
Yes.
here?
So you see it, so little r times little s is equal to the area, right?
Wait, there's a little s? I thought there was only one s.
Yeah, s.
Then
It's
why
just
did you
S.
call it little s?
There is just S. There's just S.
Okay, but notice that we have the little r is smaller than or equal to big R on 2, right?
And we just did
Yeah.
that.
Oh my god.
Yeah.
And I think Michael
This is equal to
collaborated.
We did
s
it.
times big R on 2.
We did it.
I want to shoot.
So actually, this is one of those examples where it looks complicated because it's long, right? But every step is like trivial, right? It's natural as well, yeah?
But how did you
Isn't
get
it
from
just
that
what-
question to
what
this?
anything-
It's because the left-hand side was the area of a triangle. yeah?
Okay, let's do all of that, but in real time.
That's insane. Let's do all of that in real time.
So we have
Oh god.
So it's B plus C.
This is indeed a problem.
This is a banger. This one's a banger.
Does that make sense?
How the
Wait, was the left? Oh yeah, the right was left.
But yeah, if you already just knew that 2R was smaller than or equal to big R, that's like it's just like if you already knew these formulas. It's like a 3-line proof as well, right?
Wait, Michael, could you try and prove this in 3 lines? I know what x to the e. What is e to? Oh, it's changing.
I guess when I say 3 lines, I just mean like the 3 formulas that we use.
Okay, there's a slight problem with this question. You see this, the value of this is e to the x plus c.
Huh?
There's no way that's the answer.
Alright, so I guess that wraps up the inequalities and the geometry, huh? Any questions?
Oh!
Isn't this just the antiderivative, which